Hello everyone, in this video we will talk about horses. Domesticating horses completely changed the way that people lived, traded goods, and fought battles. And from the earliest known efforts to domesticate a horse species, some 5,500 years ago, until trains were invented about 200 years ago, horses were the fastest way to travel on land. For years, scientists have wondered where modern domesticated horses come from, both genetically and geographically. And a new paper published in Nature might have the answer. An international team of researchers looked at DNA from the remains of 273 ancient horses spanning 50,000 years of history and all the regions that have been hypothesized as the center of horse domestication. They found remains of the earliest horses that were genetically similar to modern horses in the Volga-Don area of what is now Russia. These horses lived about 4,600 to 5,500 years ago. That genotype didn't start showing up in other regions until about 4,200 years ago, suggesting that is the point that modern horses began to spread. They also screened for two genes that might explain why. These were the horses that won out. One of the genes is associated with chronic back pain and painful walking in humans, and the other is associated with fear and aggression in mice. The researchers proposed that those genes made this new type of horse more docile and able to handle stress, and made them better at bearing weight and endurance running, all things you want in a domesticated horse. But this discovery tells us about a lot more than ancient horses. It tells us about ancient people. By combining this genetic information with other archaeological evidence and mythology, we can learn more about how human populations interacted with each other. Human DNA suggests that people from Western Eurasia moved into Europe between 2900 and 2300 BCE. And scientists used to think that domesticating horses is what let that happen, because it meant that the people from Eurasia could use horse-mounted warfare to dominate the local populations. But there's not really any DNA matching modern domesticated horses in Europe from that time. So it seems more likely that the European population had already declined, allowing people from Western Eurasia to just walk in. The researchers also proposed that the people of the Volga-Don region may have used their horses to conquer other civilizations because of a need for more grazing land. Meanwhile, these docile horses with fewer back injuries also made long-distance trade easier. Right now, it looks like the combination of war and trade led to the newly domesticated horses completely replacing any other domesticated equine species in less than about 1,000 years. But the researchers acknowledge that there could be other evidence behind this rapid change that's just harder to find. Which leaves us with now, where they are the only domesticated horses we know. Meanwhile, scientists have also been putting together archaeological remains, artifacts, and stories to understand the first European settlement in the Americas. The settlement is called Lance Aux Meadows and was built by the Norse at some point. From Icelandic sagas and the style of architecture, researchers have estimated that the site was probably built around 1000 CE. But no one has ever been able to scientifically determine its precise age. Scientists have tried carbon dating the artifacts from the settlement, but have gotten 150 different dates spanning 273 years. But that can't be right, because the archaeological evidence indicates that the Norse occupation of this settlement was really short. This week, scientists announced in Nature that they had used a new technique to pin the date of the settlement to exactly 1021 CE. And the technique they used actually relied on astronomy. So how? Well, carbon dating relies on measuring the amount of a specific form of carbon called carbon-14 that's slightly radioactive and decays at a known rate. So if you measure the amount of radioactive carbon-14, you can figure out how old an organic object is. And now scientists can test very small areas, as small as, say, a single tree ring. And by stacking a bunch of rings together, scientists can use science you might have learned in grade school to tell how old the tree is. Through carbon dating of tree rings, scientists have learned that carbon-14 production usually varies by less than 2% year to year. But sometimes, there will be a year with a 10 to 12% change from the previous year. That is because cosmic radiation events, like solar flares and coronal mass ejections, cause a spike in the amount of carbon-14 in the atmosphere. And when that happens, that spike can be seen in the ring that corresponds to that year. By counting the rings of wood with a known age, scientists were able to figure out that there were cosmic radiation events in 775 and 993 CE. So an international team of researchers took 3 wooden artifacts. That included that event in 993 from the Lance Aux Meadows site. Because dating tree rings isn't as simple as looking up the reference in a giant index, scientists first had to use carbon dating to figure out the range of possible dates for the very outermost ring, part of the live edge of the wood. Once they had that range of dates, they knew that the radiation anomaly of 993 would be between 26 and 31 rings, or years, back. So, they started counting back. In all 3 of the artifacts, there was a big drop in carbon-14 in ring 29, telling the scientists that that's the ring from the year before the cosmic radiation event, aka 992. 992 plus 29 years places all 3 of the objects being made and the trees being cut down in the year 1021. This specific year gives us a new reference point for thinking about when Europe became aware of the Americas, as well as context for interactions with local indigenous populations, disease transmission, and the introduction of foreign plants or animals. It also shows that using cosmic radiation events can be an effective way of dating objects, which opens the doors to learning a lot more about other archaeological sites and the people who live there. I hope you like this part.